Hello y'all and welcome. I'm Gunna Stylem, and here today I had a bit of an inspirational moment. So there's this game, it's called A Leaf on a Wind, and let me just show you real quick. So you just type it in, it'll take you to this page, and all this is you control this little stick, and it acts like a floaty little object, and it plays like fun. So hold on, whoops, whee! Now the objective is to collect all the dots. Boing. And oh, I missed it. Shoot. Oh god. No, come on. Ah, I missed it. But I was wondering if I could recreate the way this game is, the leaf mechanic. I kind of like it. I have kind of an idea for another game I want to make using this. But for now, I just want to see if I can remake the leaf. I have a general idea of how I want to do this. It's either going to be using physics or just pushing the object around using the transforms. Alright, so, anyways. So I punched up Unity. I went ahead and went into Paint, and I made a little leaf icon. It's just a 2x10 image, essentially just green. I'm going to go ahead and drag it, drop it. Is it a sprite? Yes, it is. Make sure it's centered. Okay. How do I zoom? Let's see. Do I need to zoom yet? I don't know if I need to zoom. I want to make it a little bit bigger though. Make it 2x2. Maybe 5x5, just for now. Okay, so that's it right there in that little center bit. And I want to make the leaf, so let's make leaf movement. Yeah. Boop, boop. Alright, so I made the script called leaf movement. I'm going to launch the mono dev. I'm going to get rid of this junk that I don't need at the moment. Now, the first thing I was thinking when I was coming up with the idea for this was we take the rotation. Let me load up Paint to show you guys what I'm going with here. So we take the rotation, or we take the object here. So let's say the stick is the object. And we figure out the rotation. So let's say we are rotated like this. And we figure out the amount of rotation from here to here. So whenever this is pointing in this direction, that means we're going to be facing it and going this direction. And then when it's going in the other direction, obviously we'll go the other direction. We'll add force to that direction. It's hard to explain without seeing it, so let's see what I can do here. Alright, move mono over. Alright, so the first thing I want to do, I want to build a simple bit where I can actually rotate the Doodle Maker. Alright, so let's see. Easiest way to do this. Transform dot rotate 0, 0, negative input dot get axis, and we want to get the horizontal axis. All right. That's just gonna turn it by 1. So I need to also create a variable up here called, let's call it turn speed, and we'll give it a thing of 2. And what we're going to do is take this, multiply it by turn speed. Oh, shoot. Doi. Float. I know a lot of people use public variables. I'm not a big fan of public variables. I like to come into the script and change it in the script. That way I know it's going to be changed every time I get to it. Alright. So now if I jump back into the game, I'm going to have an error because I forgot to do something. Oh, whoops. Doop, boop. There we go. Forgot to close out my parentheses. Now if I come in here and I do this, you'll see that it turns the direction I'm pressing. Now you might be wondering why I went with negative input. I just know because I've done a similar thing before where if you want something to turn to the left, you need to add a negative to it. It's a thing. Okay, so now we got it where it turns. Now we want to figure out how to make it move in a certain direction. Let's see. I guess the easiest way to do this is with the Euler angles. We could read the Euler angles because the Eulers go from Like I said, I haven't planned any of this out, so you guys are kind of going along with me here. I'll cut it a little bit. I'll try to make sure I get this out for you. So anyways, the U... Well, that's the wrong shape. Okay. Doink. Now, if I draw my stick in the middle here, our Euler angles start, so if we were to... Actually, I got a better idea. This will actually help a lot more and make more sense. Alright. So basically, if I was to rotate the stick this way, the angle at which I'm rotating increases from here, which is 0, and goes this way. And this is 90. And then if we keep going, it comes down to 180. And down here, it's 270. And then back to here, we'll either hit 359 or we'll hit 360. And then it reconverts back to 0. So at this point, we're literally just facing the opposite direction. Which is, we're actually back at our original position. Alright. So I want to figure out a way to do this. And the way I'm thinking is, if we travel in this direction, our speed should increase because we're actually going to start facing downwards. So I want like this to be almost no speed, and this to be full speed. And the direction is going to be whichever one of these sides is facing downwards. So like right now, this side is not facing downwards, so we don't have any directional momentum on this. Alright. So what I'm thinking is we need to convert these. We'll get a... I'm starting to forget how to do a lot of these things anymore. We'll get a range from here to here, from 0 to 9, or to 90. Then we'll get a range from 180 to 90, and we'll convert 180 back to 0. So we'll get the same range from here to here as we would from here to here. Yeah, it'll make sense in a second. Now, I'm going to be doing this an ugly way. Like I said, I forget how to do it the right way. So we'll do an if transform.Euler dot z, because we want the z-axis, the rotation, is less than 180. Whoops. Now we're gonna work on just the top bit right now. We'll do the bottom bit in a second. It's less than 180, and transform.Euler dot z is greater than 0. All right, so if we're inside that top range, then we're gonna do this. Oops. Keyboard no. All right, so if transform.Euler dot z is less than 91. So again, back to what I was saying, if we are less than 91, so we're in this area right here. Memory code, there we go. So if it is less than 91, then we're going to do all this. We're going to say, let's create a variable up here. We'll call it speed. Float speed. Don't need to put nothing in there yet. Speed equals. Okay, now, if I'm thinking about this right, when the right side is up, we'll have to move left. So the left side is going to get the momentum. So we'll have to do a negative. Any math we do inside of here will have to be negatized. Not actually a word, by the way. But I like it. Sounds good. Alright, so we'll do transform.Euler dot z. So we'll get the actual angle. So we'll have anything between 0 and 90. So we get up like 55, 45, 36, anything like that. And right now that'll set our speed. But I want to narrow it down so in between like 0 and 9. So basically, so we got 90. So we'll just divide it by 10. There we go. So if we end up with 90, we'll have 9. Oh, in case you didn't know, I used 91 because I used a less than instead of less than or equal to. And the reason I did this is because I want to include 90 to 0. And the next one will include anywhere between 90 and 180. But because we're using an if statement, you'll see in a second. It'll make sense. Alright, for the next one, we're going to do an else statement. And I always like to use an if statement if possible, just to make sure I don't catch any bugs. So Euler angles dot z, and if we are greater than 90. So that means we're going from 91 up until 180. Alright, for this one, we're going to do speed equals negative Actually, I'm just going to copy this because we're going to use almost exactly the same code. But for this one, we're now going from here to here. And like I said, I want 180 to be my 0. In order to do that, I need to convert this down to 0, which means I need to do some extra little bit of math. So, what I'm going to do, I use parentheses. Or not, is it parentheses? Yeah. I use parentheses like a crazy person anymore. So, I want to do 180 minus the Euler angles. Now, in case you're wondering, basically what I've done now is said, so 180 minus whatever the Euler angles are. So if we have, let's say we're all the way to the left. So when I subtract that, we get a 0, which is what we want. Now, let's say we're at 90. 180 minus 90, we'll get 90. So we're actually in the right position still. And anywhere in between, we fall in the right spot when we subtract. It's the easy way to get a 0 sum when you're on the opposite side of something. Okay. Now that we've got that, let's go ahead and save. I think I got enough here to test it at least. Oh no, because we ain't actually moving yet. Right, good point. Okay. So in order to move, we'll do transform.translate. Yeah, I always have trouble with the N. And we'll do speed, because we want to do the X axis. And we'll do 0 and a 0, because we don't want to move on the other two axes. Okay. Now, let's see what this does. Whoa. Okay, so when I turned it around... oh, shit. Oh, you know what? I realized what I've done now. Okay. The reason it's going like crazy is because the speed is coming out to be like 9, which is actually super fast. It's using 9 units per movement. What we want to actually do is increase speed over time. So up here, we're going to create another variable. We're going to call it floats. Speed M. I don't know. It just makes sense to me. We're going to use speed M. Speed M. Okay, we're going to say speed M plus equals. So we're adding the new total to itself. We're going to do speed times. You know what? Let's use 0.05 for now. So I want to take the speed number and I want to shrink it down even more. This gives us a lot more room to grow into the speed we want to get to. Times time dot delta. Oops, delta. This will help smooth it out a little bit. Okay. And I just realized I kind of want to make sure it's not... I want to make sure it stays within a certain speed. But you know what? Let's find out what this does first. Okay, so let's come back over here. What? Wow. Okay, that was acting... That's not right. Something's not right. Oh. Yeah, didn't change this, did I? Okay, now it should work. So now you see it's increasing. Oop, I lost it. Up. Oh boy. So without the opposite force, it never slows down. It just continues to increase speed. And then when I get to the opposite side of the circle, or the bottom bit, it just doesn't do nothing until it's ready to catch speed again. So in order to prevent stuff like that for now, I want to add a limiter. So I'm going to do... This is actually a new thing I learned recently, strangely enough. We use a clamp. And what this does is I add speed M. It accepts a value. Then it accepts a positive and a minimum and a maximum number. You want to do -1F and 1F. So now, it's going to say speed M equals, and it's going to go through and say speed M, and then it's going to clamp it to either -1 or 1. It will never go beyond or below that. Alright, so now when I do it, see, it's keeping this original momentum until I go, yeah. Alright, let's go ahead and add in the other side. Okay, so like I said, up here it says less than 180 and 0. So now on the bottom bit we want to do if transform.Euler.z is greater than 180. We kind of just want to flip it around a little bit. and transform.euler.z is less than 360. Now you might be wondering why I'm saying Z. That's actually a new thing. I've been talking to somebody and that's how they speak, so it's just kind of one of those pick-upable things. It's fun to say too. I love using other people's words. Just expanding one's vocabulary. Alright, for this one I'm going to go ahead and copy and paste this, because I'm just going to pretty much reuse this code, but change it a little bit. Alright, so we're now inside of here up until here. Alright, so that's what we're working on. So as long as it's less than 360 and greater than 180, we should be in this area. Oops. Okay. So now we want to say if this number is less than 271. Alright, so we're working on that left side now. We're going to do speed equals. We're going to get rid of the negative because we don't need a negative. I feel like there's something else I got to do here. Oh, yeah. Since we're working in a whole other section, we need to zero out our numbers again. In order to do this, we will subtract 180 from this one. So when I subtract 180, which is our 0, we'll get 0. Makes sense, right? Okay, and we divide it by 10, we should still get our right number. On this one, we need to do some... Oh, we need to do 360 on this one. So 360 minus whatever the number is will give us the proper number. But this number's not right. This one still needs to be... It has to be greater than 270. Right? Yeah, that's the middle number. 270 is our 90 in this case. So basically, if we have 270 on this one, we'll do 360 minus it, we'll end up with 90. Make sense? I hope so. Alright, let's test this out and see what it does. Alright, so now it's going down. When I come back up, oh, it's changing directions. Oh, look at that, I got that swag. I got that sway going. Ooh, got that leaf look. Oh, I lost it. I don't know where it went. Can I zoom the camera out? Let's do that. Ooh. There we go. So there we go. Now we're zip zooming. Up. Went down, way down. Oh. Let's see here. I'm trying to get it to go above. I can't seem to go above where I start. Oh, I know why. Okay, hold on. Let's go back to the game again. I was looking at this and I noticed if you look, it's floating upwards. I think that's why they add the float so you can go above where you start. Because otherwise, watch. If I start here, I go down and I come back up, I will never exceed where I started from. Because your speed will equal out until the point where it goes back the other way. It's like a springboard effect, essentially. Wow, wow. Boom, 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 boom. Boo. Red's bad. I'm not going to create the dots for now. I just kind of want to make this work here, so. Okay, so let's make that happen. 2D. Rigid. Rigid body 2D. Alright, so all we have to do is add a rigid body 2D and we'll affect the gravity by 0.01 negative. This will make it float up a little bit. You can barely see, but it's floating up. So now, as you can see, it continues to try to go up, but my speed is going to go against it. I've lost it. I can't really have the camera track it because then you wouldn't be able to see it anyways. I've lost it again. Whoop. But yeah, so far so good. I just gotta figure out what I want to do with this. I just love it. It's so much fun. It's just fun to look at and fun to play. Physics are just awesome, just in general. But yeah, so like I said, based on this math, as I look up, it tries to go down to the right. Whichever way it's facing down gets the most speed. Now, it carries momentum, which is why the speed m is there. It holds the momentum until... That's why I wanted to name it m. In the back of my head, I knew this, but it's like one of those things. Oops. So, yeah. So, basically what we did, this controls our turning. This reads our turning and finds out if we are on the top part of the circle or the bottom part of the circle. This detects if we're on the left or the right of the circle. And I'm sure there's an easy way to slimline or speed slimline? Something line. I don't know. Anyways, so this collects our speed. Our speed is always equal to, in this case it's going to be the negative. We get the angle and we divide that by 10. And for this one we subtract 180, so we balance out the 0. This 0 here, or this 180, we make that 0 by subtracting 180 from it. So anything between here and here, we subtract 180 and we always end up with the number that is equal to this. So it's the same as this, going from this way to this way. And basically we take that speed, whatever we end up with, we add it, we shrink it down a bit, but we add it to this, and times delta time, kind of smooth it out a little bit. And that becomes our momentum. Yeah, that's the word I was looking for, the M word. And then we use speed M and we clamp it so it never goes beyond this speed. Because if left alone, it would literally just go forever and keep going up and up and up and up and up in speed wise. And we don't want that. And then this tells it to go in that particular direction, either the X or Y. And it's always based on the direction that the object is rotated at. So it heads in that particular direction. So yeah, that's what we have.